In this video, we're going to talk about finding ratios from word problems. So there's 3 steps to finding a ratio from a word problem. The first is what I call setting up the fraction of units. So we're going to set up our ratio like a fraction, but we want to make sure we put the right thing on the top and the right thing on the bottom. So we'll set up this fraction of units. That will make more sense when we go through the example. Then we're going to find the counts that we need and put them in the right place. Our fraction of units will help us do that. And then finally, we're going to reduce the fraction with our calculator to make sure that it is the smallest fraction that it can be. So let's take a look at a couple of sample problems here. So in this first problem, a team won 22 games and lost 11 games. What is the ratio of games won to games played? So this is what I mean by our ratio of units. We want to put games won on the top, and we want to put games played on the bottom. That helps us make sure that we put the right numbers in the right place. So now let's do another fraction with the numbers. And first, we're looking for the number of games won. That was 22 from the word problem. So we put 22 on the top of our fraction. And then on the bottom, we need the number of games played. But the word problem didn't quite give us that directly. It told us the number of games that were won and the number of games that were lost. But we can find the number of games that were played by adding those two numbers. The number of games played, 22, plus 11 is 33. So that's what we need to put on the bottom of our fraction. So we start out with 22 over 33, or 22 to 33. But if we reduce this in our calculator, we're going to find out that this reduces to the fraction 2 over 3. Now there's 3 forms of a ratio. We can express it like a fraction, like that, or we could say 2:3, or we could say 2 and the word 3. All of those would be acceptable answers to that question. Let's move over to question 2. Guests ordered the following dinners for a wedding reception. What was the ratio of steak dinners to total dinners? So the thing that comes first, steak dinners, goes on the top. So we'll say steak. And the thing that comes second, total dinners, comes second. So we put that on the bottom, total. And then we find our quantities. The number of steak dinners was 50. That's right here. And we don't know the total yet, but we can add up all of these numbers and put the total right down here. 80 plus 50 is 130. 130 plus 20 is 150 total dinners. So 150 goes on the bottom. And then we remember to reduce this with our calculator. And that gives us the fraction 1 over 3. So we could also say 1:3 or 1, 2, 3. In this video, we are going to review a process of solving proportions using cross multiplication. The steps to solving with cross multiplication are very straightforward. They involve first cross multiplying. We'll talk about that in a moment. It basically means to multiply the opposite corners and then set them equal to each other. And then when we're done with the cross multiplication, we're going to divide both sides by what the variable is being multiplied by. That may not make a lot of sense if you haven't done this before, but let's first cross multiply the x and the 2. This is what I mean by multiplying the opposite corners. And I always like to start with the one involving the x, because the x is what we don't know. We're trying to find out what x is. So we multiply x and 2, and we get 2x. We're going to use an equal sign then, and then we multiply the other corners. And in this case, when it's just the numbers being multiplied together, you might as well do that with your calculator and find out what that number is. 10 times 5 is 50. So that completes step 1. Step 2 is to divide both sides by what x is being multiplied by. In this case, it's 2. So we divide both sides by 2. And we get x is equal to 50 divided by 2, which is equal to 25. In this video, I will review how to solve percent problems using proportions. So the first thing that we want to do is to use one of the formulas below. They're really the same formula, but they express the proportion in a slightly different way. On the right-hand side of both of them, this is what I'm referring to as the first formula, and this is the second formula. In the first one, we have percent over 100 on the right-hand side, and we have the same thing on the second formula. So it's the first part, the part on the left, that's different. Is over of. Is usually the smaller number. Of is the larger number. In the second formula, we use the word part and whole. This sometimes is more helpful when you're trying to solve a word problem. And we'll go through some examples of that in a moment. After that, we're going to use cross multiplication to solve these proportions. Let's take a look at some sample problems. What is 15% of 40? Now remember that for a classic kind of problem like this, which is not really a word problem, it's just sort of a math question, you're probably going to want to use that formula. What is? That means we do not know what the is part of that proportion is. We do know that it's 15%. That will go in the upper right-hand corner, and of 40. So we can set this up and put an x in the place of is. Of 40 is equal to 15 over 100. And then we cross multiply. I always like to cross multiply first with the x. So x times 100 is 100x is equal to 40 times 15, which is 600. You can use your calculator for these kind of problems. And then finally, we will divide both sides by what x is being multiplied by, 100. That will give us x is equal to 6. 6 is 15% of 40. In this video, we will review a particular kind of percent problem. It might be referred to as percent of change or percent of increase or decrease. So let's take a look at the steps that we want to use to solve a percent of change problem. The first step is to find the amount of change. You will find the amount that something changed by subtracting the old and the new amounts. You will ignore the sign. If you get a negative answer to that, you will just ignore it. In some cases, you might actually be given the amount of change, which we will have an example of that in the problems that we review, so you won't have to do the subtraction. But if you're given old and new amounts, you will want to subtract. Then you want to find the original or the old amount. That's the number that we're going to use in our formula. We're going to use a formula that follows in just a moment and use the cross multiplication process that is hopefully becoming familiar to you when we do percent problems. So the formula looks like this, and you'll notice that it doesn't look too much different than is over of equals percent over 100. In place of is, we put the amount of the change. That's why we want to calculate that, highlighted in blue here. The original or old amount in green, we will put that in the place of or the whole. The other side looks exactly the same. We have some percent over 100. So as I mentioned, this is not completely new. It's just a little bit of a twist on the same percent calculation. So here's 3 examples that will hopefully drive this home. First example, the price of a shirt increased $3 from the old price of $20. What is the percent increase? So here we are told that it increased by $3. We know the amount of increase. We could label that, abbreviating the amount of increase is right here, and it's equal to 3. The old price, it's very clear here, was $20, and we know that we need that as well. What is the percent increase? So let's set this up. The amount of increase goes on top, the old amount goes on the bottom, and we set that equal to our unknown percent over 100. Now we cross multiply. As I mentioned before, I always like to start cross multiplying with the part that involves x. 20 times x is equal to 3 times 100, which is 300. And then we, as a familiar last step, we divide by whatever x is being multiplied by. In this case, 20. That cancels the 20 out, and it leaves us with x is equal to 15. And we want to remember that this means 15%. And because the price of the shirt increased, this is a 15% increase. In this video, I'm going to do some problems involving the simple interest formula. So the simple interest formula looks like this. I equals P times R times T, like this. PRT really means implied multiplication. We're just multiplying those 3 things together. Now, I stands for interest. This is the simple interest formula. P stands for principal. That's the amount that's either borrowed or put into the bank as a deposit to earn interest on. So it's going to be the large number in the problem. R is going to be the rate that's either being earned or paid, but we want to convert that to a decimal. So for instance, if the rate was 10%, we want to divide 10 by 100, and we get 0.10 as our decimal that we would use. And the time is in years. So if you're given a time in months, you will want to divide that by 12. If you were given a time in days, you would want to divide that by 365. A little bit more about interest and account balance. So what this picture is showing us is an example where we deposit $1,000 in the bank and we earn 10% simple interest. So after year 1, they add 10%, which is $100. After year 2, another $100. So we have a total of $200. 3 years, another 100, 300. And after 4 years, they have added $400 of interest. Well, the reason I'm talking about this is that some questions might ask you not about the interest amount, but the total amount that's in the account. So when that's the case, we have to add the interest and the principal together. 1,000 plus our additional $400 leaves us with $1,400 after 4 years. So hopefully that explains that relationship between interest and account balance. First practice question, what is the simple interest on a $2,000 loan at 5% interest for 3 years? Let's first write our formula. I equals P R T. In order to find the interest, we need to know the principal, the rate, and the time. Well, the principal is going to be this big number, 2,000. The rate is going to be 5% expressed as a decimal. 5 divided by 100 is 0.05. And our time is 3 years. T equals 3. Now we just have to multiply those three things together. 2000, 0.05, and 3 years. And that gives us an answer of $300 of interest is earned over the 3 years. Now, the question asked us for the interest, so we are done. We don't have to find the balance. Let's move on to the next question. Joe deposited $5,000 in an account, earning 4% simple interest. How much would be in the account after 10 years? How much would be in the account means we need to find the balance. So let's remember to add the principal at the end. But first, we do need to calculate the interest. I equals P times R times T. Here's our P, the big amount. R, we convert to a decimal. 4 divided by 100 is 0.04. And we are doing this over 10 years. So T equals 10. So 5,000 times 0.04 times 10. And that equals $2,000 of interest. But we need the account balance. So that's going to be P, the principal, plus the interest. Our original $5,000 plus $2,000. Our balance is $7,000 after 10 years. In this video, we're going to review how to use proportions to solve map and drawing problems. The steps to solving map and drawing problems with a proportion are to first find the scale. Your drawing should have a scale. It's often at the top or the bottom. Here it is. Our scale is that 2 inches equals 10 feet. Now, the key is to recognize that that can be expressed as a ratio. 2/10. It's inches on top, 2 inches, feet on the bottom. It's important for us to keep track of the units. Let's set up the other side of our proportion. Let's say that we want to know what the width of the kitchen is in real life, the actual width of this kitchen if it was built. We know that on the drawing, it's 3 inches. This is our unknown, the number of feet. So we put an X there. Then we cross multiply. 2 times X is equal to 3 times 10. That's 30. Then we divide both sides by 2. Because we're trying to cancel this 2 out, we're dividing by what X is being multiplied by. That leaves us with X is equal to 30 divided by 2, which is 15. And that is 15 feet. If we built the house that's drawn here with this scale, the kitchen would be 15 feet wide. All right, we're going to take a look at some more examples here. Given the dimension on the drawing, what is the actual width of the study? So we have the same house here, but now we're being given the width of the study as 1.5 inches, and we have our scale down here. Scale 2 inches equals 10 feet. Okay, so let's set up our scale again as a ratio. This time I'm going to do it the other way, just to show you that it doesn't matter. We can put feet on the top. 10 feet to 2 inches. Now let's set up the other side of our proportion. Now the reason that I'm labeling the feet in the inches is that we put this 1.5 in the right place. We want to put that on the bottom of this ratio because that's where the inches go. The thing we're trying to find is up here, the number of feet that the actual study would be. Now we cross multiply. 2 times X, 2X is equal to 10 times 1.5. You can use your calculator and multiply that if you like. That is equal to 15. Now, Just as we did a moment ago, we're going to divide both sides by 2. Because x is being multiplied by 2, we want to cancel that out. And x is going to be equal to 15 divided by 2, which is 7.5. Once again, that is feet, because we were solving for the number of feet.